Welcome to Study Loop.
Let's evaluate a given integral. Here, to see if we could do partial fraction decomposition, the first thing we should do is to see if that denominator factors. So we'll look at x squared plus 4x plus 13. Here, let's go ahead and write that 1 in the front. That's our a. We see that our b is 4, and then c is 13. So to see if this factors, let's just check the discriminant. B squared minus 4ac. So what do we get here? B squared, 16 minus 4 times 1 times 13. That's a negative number. So that means that this quadratic won't factor. So in that case, this fraction already is a partial fraction decomposition. There's no more work to do there. But to integrate, we should go ahead and try some kind of substitution. U sub may not work so easily here. So let's go ahead and try to take that denominator and complete the square. So we have 4x, half of 4 is 2. You square that, you get 4. And then 13 minus 4. So we can write the denominator as x plus 2 squared plus 9, or just 3 squared. So coming back over here, x plus 2 cubed squared plus 3 squared, excuse me. There we go, and then dx. Now, let's go ahead and try a trig sub. Looking at the denominator, we should take x plus 2 to be 3 tan theta. Then, taking the differential on each side, the derivative of 2 is 0, so there's nothing else to write on the left. And on the right, 3 secant squared theta d theta. Also, looking at the denominator, we can rewrite this as well. So let's go ahead. Since we're in a new variable, theta, let's just go ahead and leave these unknown. Let's just call it theta 1 and theta 2. So on the top, we see that there's an x. So how do we get x? We get that from solving this equation for x. So subtract 2 on each side. X equals 3 tan theta minus 2. So that corresponds to the x here. Then we have dx, but we found that that's 3 secant squared theta d theta. And then on the bottom, we see x plus 2 squared. So that's just 3 tangent, and we'll square that whole thing. That's 9 tan squared plus 3 squared, which is 9. So let me just go ahead and factor out that 9. Now we could use the Pythagorean identity that tan squared plus 1 is secant squared. So these will cancel. And then let's just go ahead and write everything else out carefully. Theta 1, theta 2, 3 tan theta minus 2, and then 3 over 9 is just, we have a 3 on the bottom left over. Now we go ahead and split this into 2 fractions. And then we have, in this case, so the 3's cancel, so that's just the tan. And then here we just have 2 over 3. So just simplifying the fractions. And then the next page we'll start integrating. So the first integral of tan. For that, if you don't remember how to do this one, or just memorize the formula, you can write tan as sine over cosine, and then go ahead and let u be cosine and do a u sub. So going to the next page, we have natural log, absolute value of secant. So that was for the integral of tan. And then minus 2 over 3 theta. Our endpoints, theta 1, theta 2. And then this is where we draw the triangle to get back into our original limits. So we do not have to use theta 1 and theta 2. Let's draw a right triangle. The trig sum that we had, if you divide it by 3, so that tells you that the opposite over the adjacent is x plus 2 over 3. And then using Pythagorean theorem, you could find the hypotenuse. And if you want, you could even go ahead and rewrite that hypotenuse by just multiplying things out. And you actually see the original denominator is still there, but this time inside the radical. So now let's just evaluate secant. So we have natural log absolute value. So secant will be hypotenuse over adjacent. So that's just a radical divided by 3. And then we have 2 over 3. And then theta, you could find theta by just taking the trig sub up here and taking arctan on both sides. There's theta. So we come over here and plug that in for theta. So tan inverse x plus 2 over 3. And then now we're back into x, so we can use our original limits 0 and 1. So now the last step, just plug in these numbers and simplify as much as we can. So first we plug in 1. We'll plug it in for x. So we'll have 1. And then 4, that's 5. And then add that to 13. We have a radical 18 up there. And then also plug in 1 for x over here. So you have 2 over 3. Tan inverse of 1. And then now we plug in the 0. When we plug in the 0 for x, we'll just have a radical 13 up there. And then we'll have minus 2 over 3. Tan inverse of 2/3. And then the last thing we could do here is maybe clean this expression up a little bit. We know tan inverse of 1, that's pi over 4. Now we can go ahead and use the log properties here to rewrite these expressions. So one way to go here is we see that you're dividing there, and we know that natural log of a over b is ln a minus ln b. So you can use that fact to rewrite this logarithm. You could do the same thing for the second logarithm here. And when you do so, the ln3s will cancel out. So you have ln radical 18. And then we have minus ln radical 13. And then now we had pi over 4 here. So we have 2 over 3, pi over 4. And so that'll just be pi over 6. And then watch out for this double minus here. That's a plus. 2 over 3 arctan. Also 2 over 3. And there's our final answer.